Dear students, for the last 15 to 20 days I was suffering from health ground. I am now running my age of 65 years. That's why I was not able to post the video for the last perhaps 3 weeks. Now let us study the chapter 3, pair of linear equations in two variables. That is a very important aspect in mathematics, which almost all problem can be solved, arithmetical problem or algebraic problem can be solved through this process. That is how to solve an unknown variable. The equation is given. If one variable is there, one equation is required. If two variables is there, two equations are required, and that must be in linear. In quadratic or the power, if the power is 2, you will read in the next chapter, but in this chapter we will read about only the linear equation in two variables. Generally in algebra or in arithmetic or in say mathematics, variables we commonly take x, y, z as the variables, and the known or the constant or the known terms a, b, c in this way. There is not a clear-cut idea or clear-cut version that x and y must be taken for any unknown numbers. But in general, in practice, we can take x and y to be the unknown variables, and a, b, c, these are all the known variables. So, the general form of a linear equation in two variables, that is ax plus by plus c is equal to 0. You find here the x has power 1, y has power 1, so it is linear, and a, b, c are belongs to R, where a, b, c are constants or known numbers are, and a, b are not both 0. If they will be both 0, what will happen? If ax plus by plus c is equal to 0, if a is 0, b is 0, ultimately this term will be 0. 0 plus c is equal to 0 means c is equal to 0, meaningless. There is no variable at all. So simultaneously a and b must not be 0. A may be 0, b may be 0, but not both 0. If both will be 0, it will not be a linear equation with any variables. The condition, this is described here. If we can also express a and b both not equal to 0 as a square plus b square is not equal to 0. A square plus b square is not equal to 0. It is only possible when either a is equal to 0 and b is equal to 0. Then only a square plus b square is equal to 0. Otherwise, at no case, a square plus b square will be 0. So the condition is a and b is not equal to 0 is the same as a and b are not simultaneously 0 at a time, and the condition is a square plus b square is not equal to 0. That means this implies either a will be 0 or b will be, but not both 0. Both 0 means it will be 0, but it is given that not 0. So a square plus b square not equal to 0 implies that a and b not simultaneously 0. Simultaneously 0. Simultaneously means at a time or the same time. Okay. Now example, 2x plus 3y is equal to 5, x minus 2y minus 3 is equal to 0. Now if linear equation always represents a straight line. We have read earlier that every solution of the equation must satisfy the equation, implies it must be a point on the line. So if only one equation is given, 2x plus 3y is equal to 5, transfer into the general form, ax plus by plus c is equal to 0. It will be 2x plus 3y minus 5 is equal to 0, equation 1. Then it is given x minus 2y minus 3 is equal to 0, equation number 2. All these are two simultaneously two equations in two variables, and this is a linear equation with the variables are x and y. So how we will solve this? In previous chapter we have read that any linear equation in xy always represents a straight line. So it is a line 1, line 1, line 1, and another is line 1. Okay, you just this is line 1, this is line 2. If I will say that only one equation is given, 2x plus 3y minus 5 is equal to 0 is given. 2x plus 3y minus 5 equal to 0, only one equation is given. Can you find out the exact value of xy? No. For any value of x, we will get a y. You choose at random. At random you choose any x, you will get a y. So how many? Suppose this is the straight line L1. It is 2x plus 3y minus 5 is equal to 0. Suppose this is the straight line. So what are the points? How many points are there? Infinite points are. Infinite points. Not one point, single point, 2 point. So for any value of x, you will get a y. So how many solutions are there? Infinitely many solutions. For any x, you get a y. For any x, you get y. For another x, you get another y. For another x, you get another y. So infinitely many points. But suppose two lines are given. This equation is a line, this equation is a line, but they are not same. How they are not same, we will define later on. But for the time being, we assume that these two are not same. Suppose this is the line 1, this is the line 2. They cross here. So this line L has infinitely many points. For every x, there is a y. x1, y1, say x1, y1. In L2, in L1. In L1. Similarly, for any x2, in L2, in L2. For any x1, you will L2. But there is a certain point, at this point, it also satisfied x1, it also satisfied L2. That is known as the common point. Common point of L1 and L2. Line 1 and line 2, this is the common point. This point, it is not in L1. This point, it is not in L2. But this point, it lies both in L1 and both in L2. Otherwise, you say that this point P, suppose xy, this P point satisfies equation 1 as well as equation 2. At that time, we will say that the two lines crosses each other and the point of crossing is the solution, or it is the common point to both the lines. A linear equation always represents a straight line. Every solution of the equation must satisfy the equation. Every solution implies it must be a point on the line. If suppose this is the point, what are the points? Now come to this. Let 2x minus 3, 2x minus 3y is equal to, so I have changed this one, that two x minus 3y is equal to 3, which implies 2x minus 3y minus 3 is equal to 0. It is equation number 1. In two variables x and y which represent a straight line, let us take the following 3 points and construct a straight line. In my previous class I have told that always you take in this way x and y, you get 3 points to overtake the error in calculation. So this will be when x is equal to 0. When x is equal to 0, otherwise you can also write in this way, 2x is equal to 3 plus 3y. This implies x is equal to 3 plus 3y divided by 2, that is equal to 2x minus 3y. 2x is equal to 3 plus 3y. This implies x is equal to x plus 3y by 2, that is equal to 3 by 2, 1 plus y. So for any value of x you will get a y. So for convenience, do not take the fractional values. Always take x such a point, y such a point that it will divide, will get a integer. That is not a fraction. Okay. So if x is equal to 0, then y is equal to, not, it changes in terms of y. 2x minus 3y is equal to 3. This implies 2x minus 3 is equal to 3y. This implies y is equal to 2x minus 3 divided by 3. So for any value of x, you get a y. But for arbitrary value of x, if you take any arbitrary value of x, 2x minus 3y is equal to 3, this implies 2x minus 3y is equal to 3y, this implies y is equal to 2x minus 3 by 3. For any arbitrary value of x, you may get not a integer. Y will not be integer, it may be some fraction. But if you take cunningly, you will take some value of x which will transfer y to a integer. So let us take x is equal to 0. If it will be 0, minus 3 by minus 3 minus 1 minus 1. Okay, it is not a fraction, it is a integer. Similarly, if you take it as 3, if you take this x will be 3, there will be a common 3, it will deduct, cancel this 3. So x, if x is equal to minus 3, x is equal to minus 3, then it will be x is equal to minus 3, minus 6, minus 3, minus 9 divided by 3 is equal to minus 3. Okay, if x is equal to 3, 3 into 2, this is 6, 6 minus 3, 3 by 3, 1. So what are the points? When x is equal to 0, minus 3, 3, the corresponding value of y is equal to minus 1, minus 3, 1. So what are the points? 0, 1. 0, minus 1, this point, minus 3, minus 3, minus 3, minus 3, minus 3, 3 and 1, 3 and 1. So these are the 3 points. So ultimately a is equal to 6, 3 will be a point or not? No, cancel this. Not necessary, only these 3 points are. If you take these 3 points, then it will be a straight line. If you take only these 2 points, then also you can construct a straight line. But or this and this, you can also construct a straight line. But 3 points we are taking for this, that if there is any mistake in the calculation, suppose A will be here, another point is here, this will not be a straight line. If suppose this is wrong, if your calculation comes to here, then this will be not a straight line. So you must find that there is some mistake. So now it is on the straight line, so the 3 points are taken, is okay. Converse. Take a point 6, 3, which lies on the point L. This point must satisfy the equation. Okay, it was written. Suppose A is a point. Now, if you consider in a graph paper, then automatically this point A will be 6, 6 and this will be 3. So this point must satisfy this equation. If any point on this line must satisfy this equation, you verify. If 6 and 3, whether it is a point or not, 6, 2 into 6 minus 3 into 3 minus 3 is equal to 0. 12 minus 9 minus 3 is equal to 0. Okay. So 6, 3 is a point. Or you just put here 2x minus 3 is equal to 3. If x is equal to 6, then this is equal to 12 minus 3 divided by 3 is equal to 9 by 3 is equal to 3. So 6, 3 is a point on this. So converse, this is the converse. First you take the straight line. If any point 6 and 3, whether 6 and 3 is a point on this straight line, yes. So this also satisfies this equation, which we verify here. Now, thus any solution is a point lie on the line, and any point on the line must be a solution to the equation. Okay, if this is a point, this must be a solution to this equation. If any solution is a point, if suppose any point is a solution, this point is a solution because it lies here. Minus 3 and 3 we have taken, minus 3 and minus 3 is a point. It satisfies this equation. So that also lies in this line, and any point on this line must be an equation, a solution to the equation. If we take two different lines in a plane, then three different cases may arise, as shown in the figure. So any straight line, in any equation, in any linear equation in two variables, always represents a straight line. So any two equations will represent two straight lines. So what will be the pattern of the two straight lines? One, either it may be this, another one will be this. It is L1, it is L2. L1, L2 they may cross. L1, L2 they may be parallel, or one is L1, the other is this to this side, L2, in this same line. One is to this side, another is to this side. Okay, so it is the same line. So there are three conditions. Either the two straight lines may cross each other, and they will cross at only one point. Two straight lines will never cross more than at one point. It will not cross once here, or it will not cross here, or it will not cross here. The crossing point must be one and only one. If they will cross, otherwise if they are parallel, they will not cross. But if they will cross at only one point. And that point is the solution of the two equations, both equations, simultaneous equations, that is the only solution. And the other is the same equation. If the equation is same, then the two lines will be coincide. Suppose x plus y is equal to 5, then what will be happen? 2i plus 2i is equal to 10. It is just because, what is this? It's not it. I multiplied with this 2. Okay, this is 2x plus 2y is equal to 10. Whether it is two different straight line or the same straight line, it is the same equation. Not other than this is 1, this is 2. 1 is equal to 2. It is not any other equation, only the same equation. So they will represent the same straight line, this one. Otherwise, they may be parallel or they may cross each other. So there are the only three conditions. Two lines may intersect exactly at one point, point P. Lines will be parallel, not intersecting. Parallel means non-intersecting. And two lines may coincide, means the same one line. Same one line, that is the coincide. They will coincide with each other. Okay. Now, graphical representation of the three cases. Now we will want to explain it graphically. How we will graphically represent the three cases. X minus 2y is equal to 0. We represent one straight line. 2x minus y is equal to 6, another line. Let us find out the points. The same process. Equation 1, 0, 0, 4, 2, 2, 1. You see here, 4, 2 is here in straight line 1. 4, 2 is equal to also in straight line 2. And we have read earlier that only if they have a common point, only one common point will be there. No further common point will get. No any other point will get which will be both in L1 and L2. Because at this point they will cross each other. It is L1, it is L2. they will cross at this point, and also during find out the process, during find out the points, we also know that this 4 2 4 2, so this is the solution. But let us verify it practically. In graph paper you can construct this, or also in this rough. If you take measure just manually, you will take this is T1, but if you take manually this, suppose this is 1, this is 2, this is 3, this is 4, this is 5, this is not the process. It is not a graphically. Even if you are drawing manually, you take in such a that as if they will be equal distance. 1, 2, 3, 4, all these things. So I have taken in this way. It is 1, 2, 3, all these things. The points are taken, and you are finding that L1 and L2, they cross at each other, and this point of crossing is 4, 2. So this is the equation of this is the solution of both the equations. Simultaneously, it is a solution to L1, it is a solution to L2. So it is solution to both L1 and L2, means it has the only one solution, that is x1, that is 4 and 2. So another thing is, if any linear equation in two variables x and y, if two equations are given, then we will exactly get one solution only, because they will meet at one point. Okay. Now L1 L2 crosses at point Q, whose coordinates are 4, 2. This point is common to both L1 and L2, and this is only point which satisfies both the equations. It will satisfy both L1 and L2. Note: in a plane, to draw a straight line, any 2 points sufficient, but to overcome any mistake during calculation, to choose the 3 points, as I have told earlier, 3 points. Now another question, another equation: x plus 2y is equal to 4, 2x plus 4y is equal to 16. Then if you are taking the points, then you can verify that these 2 points are not, the two straight lines are parallel. Clearly L1 and L2 are parallel and have no common points. You verify that x plus 2y is equal to 4, x plus 2y is equal to 4, x plus 2y is equal to 4, and 2x plus 4y is equal to 16. You verify that. 2x plus 2y is not it 2x, 2 into x plus 2y is equal to 2 into 4, 8. If it will be this, then the two lines will be coincide. I have said earlier, but it is something different. So these two are not same line, they are two different line. But as it is the unknown terms which bears the unknown terms or the variables, it is to 2 times, but the known terms is not 2 times. At that time it will be parallel, and the details will I will tell you later on. But for the timing, just from the graph you conclude that these two lines are parallel. Okay, they have no common points. For any value of x and y, two equations LHS is 2 times LHS of 1, but right hand side differs, so we get no common solution. At that time we will get no common solution when it is the 2 times, but it is no 2 times, it is something different. At that time it will be parallel. Another, because I have told you that there are the 3 cases, one they may cross, they may parallel, or they may be same. So 3 different questions are taken, and that was constructed with graph, and practically you are verifying this through the graph. Okay. Now the last one is the same equation, 2x plus 3y is equal to 9. You verify here, 2x into 2, 4x, 3y into 2, 3x, 9 into 2, 18. So it is not the 2 different equations, they are the same equation, just only it is 2 times of the 1. This implies second equation is equal to 2 into first equation. So they will represent one straight line. Then whatever the points you are taking, 3, 1, 3, 1, 0, 2, it is 6 minus 1, you verify 6 minus 1, you verify that they are the same line. Any other point, you even if 0, 3, 3 minus 1, it is same here. Suppose you are taking some other value here, not this, then also it will be the same straight line. Okay. Now, equation 1 and 2 represent the same line. If we just look these two equations, we can find that 1 and 2 are identical, as 1 is 2 times 1. Okay. 1 is 2 times, second is 2 times 1. So ultimately 1 and 2 represents a single equation, implies a single straight line, and 1 to one side. Now, graphical method of solution of a pair of linear equations. So I will solve this graphical method. So from the graph, if we verify in algebraically, because x 4 minus 2 into 2 is equal to 0, 2 into, so case 1, x is equal to 4, y is equal to 2. X minus 2y, 2x minus y is equal to 6. So this equation, it is the point we have got that 4, 2. So 4 and 2 we have the solution. Now if we verify in algebraically, because 4 minus 2 into this is equal to 0, 6, thus 4 and 2 is the solution of the both the equations. From graph we also found that 4, 2 is the common point of both time where both intersects, and this is the one and only one. One and only one means that point and only that, not any other where. Solution in two lines cross at a single point for this pair of linear equation in two variables. Since one solution, it is called consistent equations. Since one solution, it is consistent. It consists, it exists, it is possible, it is feasible. So that's consistent word is used here. Now, in case 2, x plus 2y is equal to 4, 2x plus 4y c, two lines are parallel. They have no common points and no common solution. They have no common solution. Okay. A pair of linear equations which has no solution is called an inconsistent pair of linear equations. If they have no common solution, then we say that the two pair of linear equations are inconsistent. Means they are not feasible. It is not feasible to get a common solution. Okay. In case 2, this is the same, you represent the same line and one coincides with the other. So whatever point in line 1 is also a point of line 2. If line 1, line 2 is equal to also the same, so any point on line 1 must be a point on line 2, or any point in line 2 must be a point line 1. So any solution in L1 is also a solution to L2. So how many points are common points are there? Infinitely many. So it has infinitely many solutions. For every x you will get a y. So infinitely many common points, infinitely many solutions. Common points means a solution, I have told earlier. So infinitely many solution means consistent equation. It is also consistent. Even though it has infinitely many solutions, but it has a solution. So the term word is consistent used here. Thus in case of pair of linear equations, if it has no one solution or infinitely many solutions, it are called consistent equations, otherwise called inconsistent one. Dependent pair. A pair of linear equations which are equivalent and thus infinitely many distinct common solutions is called dependent pair of linear equations of two variables. Because dependent means one depends other. It is only one, a pair of linear equations which are equivalent and thus infinitely many distinct common solutions is called dependent pair of linear equations in two variables. One depends with other means it has no dependence. This will not this depends with this. L1 depends on L2 because they have infinitely many solutions. Whatever the point in L1, it is also in L2. Whatever point in L2, it is also L1. So one depends on other. So there are infinitely many solutions. At that time we will use the dependent word, but this does not depend. L1 does not depend on L2. It has some separate equation, separate points. It has also separate point. They cross at one point, it is immaterial, but it does not depend. The L1 depends on L2. Okay. Graphical method of solution consistence. Summary of the above aspects. What is the summary? A1x plus b1y plus c1 is equal to 0. A2x plus b2y plus c2 is equal to 0. So, are the two linear equations in two variables x and y, then the following things will happen. So, these are the two equations. A1x plus b1y plus c1 is equal to 0. A2x plus b2y plus c2 is equal to 0 are two linear equations in two variables x and y, then the following things will happen. So, what will be the cases if these two things will, these two equations are given, then what are the possibilities are there? In which case these three things will happen. Okay, either they will cross, or they will parallel, or they will be equal. So what should be the condition? For what should be the condition? If these two equations, then either it will cross each other, or it will be the single line or coincidence line, or it will be parallel. So in the next video I will tell you in details. Okay.